So here we're asked to calculate the cross product of these two vectors and then to verify our answer by using the dot product. So let's begin by reviewing what exactly the cross product of two vectors is. So suppose you have a vector called vector A, and then you have another vector called vector B, and they're placed tail to tail. Then the cross product, known as vector A cross vector B, is a third vector that is perpendicular to both vector A and vector B. Vector A cross vector B exists only in three-dimensional space, and these three vectors form what's known as a right-handed system. You can see the right-handed system in this image here. So basically, if you take the index finger of your right hand and you point it in the direction of vector A, and you take the middle finger of your right hand and you point it in the direction of vector B, then your thumb should naturally point in the direction of vector A cross vector B. So let's start on the question. To begin, I would recommend labeling the first vector you have as vector A and the second vector as vector B. Now we're going to list the components of vector A in a specific order. So first we're going to list the second component or the middle component, then we're going to list third component, then we're going to list the first component, and finally finish off by relisting the second component. So that means for vector A, we would have -1, 1, 5, and -1 again. We're going to do the same thing for vector B. We're going to list the middle component, which is 4, the third component, which is 7, the first component, which is 2, and relist the middle component, which is 4. To find the x component of vector A cross vector B, we're going to take the down product of -1 and 7 and then subtract it from the up product of 1 and 4. So x is equal to -1 times 7 minus 1 times 4, which is equal to -11. To find the y component, we're going to follow a similar pattern. We're going to take the down product of 1 and 2 and subtract it from the up product of 5 and 7. So y is equal to 1 times 2 minus 5 times 7. This is equal to -33. And to find the z component of vector A cross vector B, we follow the same pattern once again. So you take the down product of 5 and 4 and you subtract it from the up product of -1 and 2. So z is equal to 5 times 4 minus -1 times 2. And this is equal to +22. Now putting that all together, we get vector A cross vector B is equal to -11, -33, and 22. So if you remember back to the original question, we know that it asks us to verify our answer by using the dot product. If you remember back to the beginning of the video, we know that vector A cross vector B is perpendicular to both vector A and vector B. We also know that the dot product of any two perpendicular vectors is 0. So if this answer is correct, then vector A dotted with vector A cross B should give us 0. And the same thing applies for vector B dotted with vector A cross vector B. So let's try that out. So in the first case, we have 5, -1, and 1 dotted with -11, -33, and 22. Now to dot two algebraic vectors, you simply take the product of their x values, add that to the product of their y values, and then add that to the product of their z values. And plugging that into our calculator, we realize that it is 0, so this is true. Now let's do the same thing for vector b. So you take 2, 4, 7, and then dot it with -11, -33, and 22. So once again, to dot these two vectors, you take the product of their x components, add that to the product of their y components, and then add that to the product of their z components. Plugging that into our calculator, we realize that this is equal to 0. So vector b is perpendicular to vector a across b, and we also know that this answer is correct.